Good morning, student. Today we are going to start our unit number 3, that is the air compressor. And in air compressor, we have to study about the reciprocating compressor. What are the different applications of reciprocating compressor? Then we have to understand the working of single stage and two stage compressor, and we have to represent the working of single stage and two stage compressors on PV diagram and as well as TS diagram, pressure volume diagram, as well as temperature entropy diagram. Again, we have to understand what is the intercooling, how we are using intercooling to increase the efficiency of air compressors. Then we have to analyze the air compressor, reciprocating air compressor. We have to understand the different performance parameters such as pressure ratio, compressor capacity, pre-air delivered, volumetric efficiency, isothermal efficiency, and what are the different methods are there to save the energy, that we have to understand. And after that we have to study about the rotary compressors such as screw, centrifugal vane type, lobe type, axial flow type, and we have to understand what are the different differentiation between rotary and reciprocating compressor. So initially you should know about what is the air compressor. We will study about the compressor. So compressor, what is a compressor? Compressor is a device, is a mechanical device, is a mechanical device used for increasing the pressure of the gas, used for increasing the pressure of the gas. So it is a device which take atmospheric air, and it will compress it, and it will supply the pressurized air to the reservoir means what we are doing, we are using the compressor to increase the pressure of the gases. So in air compressor, we are increasing the pressure of air, and that high pressurized air we are using for the different applications. So initially, this is the work consuming device. This is not the work producing, such as internal combustion engine. So internal combustion engine was work producing devices. So compressor is just opposite of IC engine. We have to supply some work, and that work will be supplied by the prime mover. It will be supplied by the prime mover. We are using some prime mover, and that prime mover is utilizing. If you're analyzing it, so you can easily see that, if you see here, if you're looking this, so this is the prime mover, this is the prime mover. So to this prime mover we are adding heat. So this, we can say, this is a engine or prime mover. From this prime mover we are supplying the work to the compressor. We are supplying to the work to the compressor, and compressor will suck the low pressure air, such as atmospheric air, and that atmospheric air will compress due to the piston movement, by creating the variation of volume inside the cylinder, and that low pressure air will get compressed, and that will supply to the reservoir. Now in this process, there is a while compressing, there will be the increase in internal energy will be happen, because we are applying work on the gases, and we are compressing it. Due to that, what will happen, internal energy of the gas will increase, and due to the increase in internal energy, there will be the heat will be produced, and some of the heat will be rejected to the coolant. Some of the heat will be rejected to the coolant, and some of the heat will be rejected by radiation. It will be rejected by radiation. So for that, while using the cylinder, we are using the cylinder with cooling arrangement. So this is the basic concepts of compressor. So for running the compressor, we need a prime mover. Prime mover. We need a prime mover. So here, compressed air is very much important for achieving many tasks done in the industry. So these are the some uses of compressed air in industry. So we are using compressed air for air engine. Then we are using for producing the an air blast for a workshop. Again, we are using it for spraying the fuel or atomization in boiler furnace. We are operating many types of pneumatic drills and tools. We are operating pneumatic brakes for locomotive rolling stocks, and again we are using this for pumping the water by compressed air. Apart from that, again we are using this for the gas turbine power plants as well as air conditioning plants. Then again we are using it for the maintenance of the farm, processing of food. We are using it for some of the commercial use of compressed air are there for filling air in the tubes of automobiles, for cleaning of automobiles, for spray painting, then for injecting fuel in air injection diesel engine, for cooling of large buildings. So these are the many applications of compressed air is there. So we should aware about this application because as the large applications are there, so you should um, understand the detail working and what are the different parameters on which the efficiency of compressor is depend. So for that we have to understand the working of air compressor. Then what are the different basic cycles are there on which air compressor working is depend, that you need to understand. So here this is the just piston cylinder arrangement for achieving the compression of air is there. So now as we have discussed, so this is the cylinder along with the cooling jacket, because we know that while compressing the gases there will be the heat release will be happen due to the increasing internal energy of the system or gases. So here what are the different component we can see over here. So main components are crankshaft, crank, connecting rod, piston and cylinder, and these are the cooling jacket we are provided along the three sides of the cylinder. So here, due to the movement of the pistons, because piston is moving inward to outward direction, so due to that there is a variation of volume will be created inside the cylinder, and due to that there will be the compression of gas will be occur. So these are the basic parts you need to aware of this, and we have already discussed this type of arrangement while studying about the IC engine, so SI or CI engines. So some of the terminology we need to understand prior going for the working of the single stage and two stage air compressor. So these are the single acting compressor, double acting compressor. So if the air admission from the atmosphere is on only one side of the cylinder, so that we can calling as a single acting. If it is on the both side of the piston, we are calling as a double acting compressor. So again whatever the intake pressure, absolute pressure of air entering to the compressor, so absolute pressure entering to the compressor, the absolute pressure of air we are calling as a intake pressure. We are calling it as a intake pressure. And the pressure, the absolute pressure of air leaving the compressor at outlet, we are calling it as a discharge pressure. So now there are two terminology we have discussed: intake pressure and discharge pressure. Then the ratio of these two pressure is called as a compression ratio or pressure ratio. The ratio of discharge pressure to the intake pressure we call as a compression ratio. So three parameter we have discussed: intake pressure, discharge pressure, and compression ratio. So then what is the compressor capacity? So compressor capacity is the volume of air delivered by the compressor. Whatever the volume of air will be delivered by the compressor, that we are calling as a compressor capacity. Now there is a one more parameter is there, that is the FAD, free air delivered. So this free air delivered, it is related somewhat with the compressor capacity, but if the compressor capacity we are reducing to the intake normal temperature pressure, then we are calling as a free air delivered. Now what is the free air delivered? Free air delivered is the actual volume of air delivered by the compressor. It is the actual volume of air delivered by the compressor when we are reducing it to normal temperature pressure. Normal temperature pressure. Then we are calling this as a free air delivered. Then swept volume. Swept volume we have already discussed in IC engine. The volume displaced by the piston movement between the two dead center is called displacement or swept volume, and it is equal to the multiplication of stroke into piston area. Stroke into piston area. So already we have here. So this is the piston area and this is the stroke. This is the stroke. So this is the multiplication of area into stroke. This is the, now we'll discuss what is the how the compression will take place. How the compression will take place. So now here, as you can see, this figure is showing as a single acting piston cylinder, and here we can say that now for understanding the working we can use this one. So here now see, just we have discussed. So this is the top dead center. What is this? This is the top dead center, and the volume in between the cylinder head and the top dead center, that is a clearance volume. There is a clearance volume. And if you are saying this is as a bottom dead center, so volume in between top dead center and bottom dead center, it will give you the swept volume. It will give you the swept volume, and total cylinder volume will be equal to Vs plus Vc. Vs plus Vc. So just we have discussed about clearance volume. What is the top dead center? What is the bottom dead center? What is the swept volume? And what is the total cylinder volume? Now here you can see this is the suction wall and this is the discharge valve. So this suction wall is relating, it is interacting between atmospheric pressure. We can say this is the P atmospheric and pressure inside the cylinder. And this discharge pressure, it is interacting between discharge pressure and we can say pressure inside the cylinder. Now we have already discussed the pressure inside the cylinder is keeps on varying. It is keeps on varying due to the piston movement. Due to the piston movement, as the piston is moving from TDC to the BDC, there will the variation of pressure will be occur, and due to the variation of pressure, there will be the opening of valve will be occur. So this valve is operating due to the piston, due to the variation in pressure across the valve. Now we'll discuss about the how suction valve will get open. Now see, as the piston is moving from top dead center to bottom dead center, so there will be the pressure will get reduced. Now you can say that now uh, pressure inside the cylinder. As the piston is moving from TDC to BDC, the pressure inside the cylinder will keeps on falling. When this pressure inside the cylinder will fall below the atmospheric pressure, so this atmospheric pressure will open the suction valve. It will open the suction valve, and as the valve is opening and as there is a suction is created inside the cylinder, air will get supplied to the cylinder, and the whatever the air is supplying to the air, there is a volume of suck air inside the cylinder. Now see, at this point the absolute pressure of air entering at the compressor, that we are calling as the intake pressure. Now once the air will get sucked inside the cylinder till the piston is moving till to the bottom dead center. When it is coming to the bottom dead center, it will reverse its direction. Direction, and it will start moving from bottom dead center to the top dead center. It will start moving from bottom dead center to the top dead center. As the piston is moving from bottom dead center to the top dead center, the pressure inside the cylinder will keeps on increasing. It keeps on increasing. Once it's increasing above the atmospheric pressure, the suction valve will get closed. It will get closed, and both valve will get closed, and as the piston is moving upward toward the bottom top dead center, the pressure inside the cylinder will keeps on increasing. It keeps on increasing, and when the piston is approaching top dead center, the pressure inside the cylinder will come nearer to the discharge pressure. It will come nearer to the discharge pressure, and add nearer to the top dead center, it will overcome the discharge pressure, and as it is overcoming the discharge pressure, discharge valve will get open, and this compressed air will supply to the reservoir. It will supply to the reservoir, and this, as soon as the pressure is reset to the desired pressure equal to the discharge pressure, so it will supply to the delivery valve will get open, and it will supply to the receiver. And if you are seeing the overall working of a reciprocating compressor, so we have understand there are two strokes are there. One is the suction stroke and other is the compression stroke, and with the help of this stroke we can compress the air, and by compressing the air we can supply this compressed air to the reservoir, and in reservoir there will be the compressed air will be there. Now see, here we have already understand the working of reciprocating air compressor, but compression can be achieved by different basic processes. So now we have already seen, while compressing the air from suction pressure to the discharge pressure, there will be the increase in internal energy will be occur. As the internal energy is occurring, so if you are reducing the internal energy, if you are reducing the internal energy, means if you are achieving means while compressing the air, the internal energy of air will be keeps on increasing. As the internal energy increasing, it will reject heat to the ambient. So if you are reducing the internal energy while compressing the air, you can save the work supplied to the atmosphere. Now we'll see, for understanding that we have to understand the basic compression processes. That basic compression processes are there: isothermal compression processes, polytropic compression processes, and adiabatic compression processes. Now see, if you're now in isothermal compression process, so what will be the, so we have already discussed what is the isothermal process, what is the polytropic process, and what is the adiabatic process. In isothermal process, index of compression is 1. Index of compression is 1. In polytropic process, index of compression will be from 1 to 1.4. And in adiabatic compression process, it is a index of compression is a 1.4. Now how we can achieve the isothermal compression process? If you are completely reducing the internal energy to zero, then we can say that the temperature of air at the suction point is equal to the temperature of air at the discharge point. Now we have to understand this how. So now this is the point number one. If just I am trying to create logic in your mind. Now see, this is the point number one, at which suction air is supplied to the compressor, and we are trying to compress it. We are compressing it to higher pressure. So this is the point number two. This is the point number two. So this is the discharge pressure, and here it is the suction pressure. Now in practically, if you are compressing this pressure to the discharge pressure, obviously there will be the increasing internal energy will be occur. Increase in internal energy will be occur, and as the internal energy is increasing, and we know that the internal energy is a function of temperature, so obviously whatever the T1 is there and T2 is there, that will not be equal. That will not be equal. As the T1 and T2 is not equal, so we cannot say that. So whatever the compression is occurring, that is the isothermal compression process. So when T2 is equal to T1, when T2 is equal to T1, then only we can say that the whatever the compression will be occur, that may be isothermal compression. If the entropy of the compression is equal, so if I am saying S1 and entropy of discharge air is S2, when I am comparing S1 is equal to S2, means we have not, the entropy is constant, means there is a no increase in entropy is occurring, and at that time we can say that if the S1 is equal to S2, then we can say that that compression will be adiabatic compression is, because entropy is same, and at that condition we can say that the adiabatic compression is achieved. So isothermal and whatever in between these two, we can say that that is a polytropic compressor. That is a polytropic compressor, means the, not we are following the second case. So this is the second case and this is the first case. If you are achieving first case, it will be the isothermal compression. If you are achieving second state, then it will be the adiabatic compression. And if the case is in between, so we are not achieving case 2 and case 1, so case is in between case 1 and case 2, then it will be the polytropic compression process. So this is the basic analysis of this compression process. And in isothermal compression process, we are reducing the increasing internal energy of the gases to zero. That's why the whatever the work supply required for compression, isothermal compression will be minimum. So in isothermal compression, so we have to supply minimum work. As we are supplying minimum work, we can increase the efficiency of compressor. We can increase the efficiency of compression in isothermal compression. So we can see that this isothermal compression we can assume as an ideal compression, assume as a ideal compressor, and most of the time we are trying to approach the isothermal compression, because we know that we cannot stop increasing in internal energy. There will be the increasing internal energy will be there, but for reducing internal energy at the stage of stage 2, we can use the different means. We can use the cooling arrangement in the form of different means. We can use the different means so that we can reduce the internal energy by using cooling methodology. So for different methodology we can apply for reducing the internal energy by cooling method, so that we can approach the isothermal compression. So here I have analyzed the detail in detail, how we can, which compression is the ideal one, and but practically we cannot approach the isothermal compression. So for approaching isothermal compression we can use two-stage compression. Again we can use different cooling methodology, so that we are going to discuss in coming lectures. So I think today we can stop over here, because we have already analyzed the basic analysis of air compressor, and that you should, I think that everybody should think logically, how we are approaching the compression, and how which compression is the ideal one. But ideal compression is not achievable. So for approaching this ideal compression, we are using different means that we will discuss in coming lectures. Thank you.